Hello guys, welcome to the portal, the mathematical science portal, the only portal that offers you very nice science at a very decent and slow pace, quality content. I welcome you. My name is Karabosel. Okay guys, let's talk about substitution reactions involving alcohols and haloalkanes. Okay, so now this type of substitution deals with the conversion between haloalkanes and alcohols. Okay, so I can convert between I can convert from a haloalkane to alcohol and from alcohol to haloalkane. Okay, so now here the first one, I want to convert from haloalkane to alcohol. So what do? It means we must add water to haloalkanes, and adding water to haloalkanes, it's called hydrolysis. Okay, so it's adding water to a compound, so hydrolysis. So now when we add water to haloalkanes, the chlorine is substituted with the OH group. Okay, substituted with the OH group, so they change places. Okay, so now this OH, the red OH, was with the hydrogen, so now it has swapped with the green chlorine. So even here in the product you can see that the chlorine it's green, it's still the same chlorine. Okay guys, so let's talk about conditions, reaction conditions. You will notice that I always talk about conditions because conditions are the most important thing, because without conditions, without the correct conditions, we won't have the correct product. Okay, because we won't know if what we are doing is correct or wrong. So now you must always write your conditions. If you don't write your conditions, you will get penalized, you will lose marks. So now the reaction conditions, for this type of reaction, okay, so now we need to use a strong base, right? So the base that we are going to use, it must be dilute, right? Not concentrated. Remember, in in the hydrohalogenation we use a strong concentrated base, but here we use a dilute a strong base. Okay, so now dilute strong base such as sodium hydroxide and potassium hydroxide. Okay, and then the heat that we use, it must be it must be mild, almost the same temperature as room temperature. Just heat it a little bit to kickstart the reaction. So but the heat, it mustn't be too high. If it becomes too high, we are going to have elimination, which is not what we want. So with mild heat, you must write mild heat. If you just write heat, you will get penalized. Okay, so this mild heat is approximately room temperature. All right, so and then the solution must be in aqueous solution. must be in aqueous solution. Aqueous solution simply means water. So meaning that if we are using a base to perform substitution, it means the base must be dilute, and then it must be in a solution of water. Okay, it must be in water. So, and then if we are using water as a reactant, water must be in excess. Okay, water must be in excess, must be in excess when used as a reactant. Okay, and then our haloalkane must be dissolved in ethanol. So it means that we must use ethanol as a solvent, with ethanol as a solvent. Okay, so now let's do a nice example. So this substitution, it can take place in tertiary, primary, and secondary alcohols. Okay, so now let's say I have this. I have C. Okay, and then here I have Cl. Okay, so plus potassium hydroxide. So this potassium hydroxide, its condition must be it must be dilute. Okay, so the base must be dilute KOH. Okay, and then mild heat. So I'm going to get now OH. The OH is gonna be substituted to the chlorine. Okay, it will be here. Okay, plus KCl, potassium chloride. Okay, so this was number one. Another scenario whereby we have the same molecule, CH, and then CH3. CH2, CH, okay, and then CH3. Let's say here we have Br. Okay, we have Br here, so plus water. So if we are adding water, the water must be in excess. Okay, and then we have to have an ethanol as a solvent. Okay, and mild heat. So now Now our product will be CH2, CH3, CH2, C, and then now we're going to have OH there, and then CH3. All right, so plus HBr. You see, so there's our Br there. So that's all there is to it, guys, with the substitution. So one thing that you need to note is that on a chart of reactions, like how they ask on the question paper, you know, you will find some point whereby there is a primary alcohol. They say you must create a primary alcohol. So the easiest way to create a primary alcohol is to do a substitution of a primary haloalkane with water or a strong base or a dilute strong base. That's the easiest way to get a primary alcohol. Okay, so you can tell that, okay, by addition, when we use addition, the only product that we can get when we use addition, the main product that we can get is the Markovnikov product, which is it will either be secondary or tertiary depending on the situation. So now, but if we have a butanol, one butanol, for example, so if the OH group is at carbon number 1, so you must know that for them to get that OH group to carbon number 1, they must have used substitution of haloalkanes with water, meaning hydrolysis. Okay, so yeah, that's what you must note when you answer your questions. Know your rules. Know the rule of Markovnikov, that when you add the OH group or the Br to an alkene, it will go to the most substituted carbon. The OH and the Br, they will go to the most substituted carbon. So you cannot have a primary product, a functional group that is on the primary carbon. Okay, so the only way to have that is if you do a substitution. You substitute a primary haloalkane to what? To alcohol, and vice versa. Even if you go from a primary alcohol to a primary halogen. So that's how it works, guys. Thank you. Keep well. I think for the, oh man, I'm getting old. We haven't done the other one, the one that is formation of haloalkanes from alcohols. We haven't done that one. Okay, let's do it. Okay, all right. So okay, so here haloalkanes, the conversion goes like this: from haloalkanes to alcohols. Okay, so now let's talk about conditions, reaction conditions. So now uh, for tertiary, uh, for tertiary halo okay. Okay, so for tertiary alcohol, substitution works best at room temperature. At room temperature. Okay, and then for primary and secondary alcohols, this requires a high temperature. Okay, so it requires a bit of temperature. So for secondary, and primary alcohols, high temperature is required. So with that being said, it means that, for example, if I say CH3, here I have CH3, and then I have an OH here. So plus HX. So what will I get? Remember substitution. Here I have an entire OH, and then what do I have also? I have the halogen. So now the halogen and the alcohol, they are going to exchange. Okay, so I'm going to have CH3 here, and then HX. Okay, no man, sorry about that, but just have an X, not HX. Just have an X. Just have an X. Okay, so now plus water, plus water. Here's my OH. Okay, so now the conditions for this one is just what? Room temperature. And then let's have a secondary and a tertiary. So if I have this CH2 CH, and then here I have an OH, then CH3. What is this? This is a secondary alcohol, so plus HCl. Okay, so now the temperature must be high temperature. Okay, or just heat, must be high temperature. And then now what's going to happen, I'm going to have my nice product substituted. Then I'll have the Cl here, I'll have the water here. So here's my water, here's my water, and then here's my Cl. Okay, so even for primary will require high temperature. Only the ones for tertiary alcohols will not require any amount of energy, just the room temperature. It's fine for the tertiary, right? This one is tertiary, this one is secondary. Okay guys, so we are done with substitution. So now from here we're gonna go to esterification. Okay, gonna go to esterification, and then that's it. Will be done with reactions, and then we'll do summary of reactions, and then do question paper, some previous question papers, and show you how this works. Okay guys, keep well. Thank you.